Make in India policy is accelerating foreign direct investment. Manufacturing has received a boost and companies are gearing up to establish efficient and reliable supply chains. From a production perspective, it combines the digitalization and smart machines concept emerging from Industry 4.0 and smart manufacturing. Samarth Udyog is India's response to the fourth industrial revolution. This journey is not one just about technology. It's also about changing the way we work, changing the way we think. What is unique to India is our ecosystem, which comprises a large number of small and medium enterprises.
Manufacturing is also a national priority, and it comes down to creating opportunities for SMEs to actually respond to this need. They need to be globally competitive.
The Indian ecosystem actually makes a very hard entrepreneur out of SME. So if a SME has the information to its market, the market demand, the logistic chain, the raw material chain, then I think Industry 4.0 actually comes to the aid of SME.
One is improvement in the means of manufacture. Second is the harnessing of the power of data which emanates from the manufacturing industry.
Getting small and medium enterprises is both exciting, but it's very daunting. Many of them are still the stage of pre-automation. We've factored in our journey the very process of bringing them in, taking them up the curve right up to Lean Six Sigma. Our first attempt would be to set up a small lab in which we will get the SMEs to come and see by example simple production processes, engage with them on what they've actually been doing in their current automation, and then slowly get them to see that the integration of IT and OT is not such a big situation.
We implemented this e-factory concept first in our manufacturing facilities in Japan and China. Our e-factory solutions are set to benefit Indian manufacturers to produce high-quality products at high speed to cater domestic needs as well as overseas market.
Smart manufacturing is basically a basket of technologies that starts from the IoT, connectivity, cyber-physical system, augmented reality. So the role is basically to demystify the technology in the forefront, understand the technology as a teacher, and then the role is to pass on this knowledge to the people.
In the next 2 years, you will see hundreds of companies doing their R&D activities out of the IIT campuses, and that is where these industries will work closely with our faculty and students, work in a multidisciplinary kind of a fashion.
The automation industry also has a great opportunity to build upon its infrastructure, and I mean specifically with regard to the system integrator community. Not all of them have a national footprint. It's not easy for customers to find where they operate, what kind of uniqueness they bring in terms of their solutions. So as AIA, our job will be to bring them on board at least one platform.
We want to keep in mind where the Indian industry is going to be 10 years from now and prepare our students to meet those kind of challenges, to propel the Indian industries to the world stage.
Technology has a very crucial role to play in this. I think technology is that X factor which can bring about the transformation.
In my opinion, by and large, automotive and pharmaceutical are two important verticals that will benefit with Samarth Udyog.
Right place to start from is what is it that I want to do with my business? Where is it that I want to take my manufacturing operations to?
We have the capacity to be the leaders, and we should now take charge.
Good afternoon, everyone, and welcome to this session on industrial IoT. We have picked 4 topics for the overview sessions, the level 1 of the masterclass, and this happens to be the 3rd topic. We have covered the basics on smart manufacturing. We have covered the basics of augmented reality, and today we are discussing the basics of industrial IoT. Industrial IoT, as all of you are aware, is the basic foundation on the layer on which we cross from the physical world to the cyber world and vice versa. So it's a very core topic, and today you will have the chance to listen and demystify the various technologies which are being spoken about. We will be having one more session in the overview classes, which is on machine learning, and that will be announced sometime for October. Before I start, I just want to lay some of the ground rules for today's session. The ground rules are very simple. We will not be allowing any of the participants to open their audios, so their mics. So please send in your messages. If it's a logistics challenge you are facing or a general comment, please post that on our chat box. Our backend teams will attend to that. If you have questions on the lecture and you would like Dr. Jha to answer those questions, then please post it on the Q&A box. So you have 2 facilities at your command. One is the Q&A box and another is the chat box. Chat box is for general comments and observations, and the Q&A box is for the specific technical questions that you may have. Many of you are attending this course after doing the overview on basic manufacturing, and therefore you may not require any introduction to Dr. Jha. But for those who are attending first time, let me tell you, Dr. Jha is a practicing engineer who moved into academia about 10 years back, and he has been working in the area of smart machines. He has been working in the area of computer-aided design, computer-aided manufacture, simulation, industrial automation, and since our project of Samarth Udyog was launched in 2017, he has been very actively pursuing the technologies of Industry 4.0, such as cobotics, such as smart sensors, industrial IoT, augmented reality, machine learning, and artificial intelligence. So you have the privilege of attending a class by a stalwart who spans and covers a 360-degree view of the topic. However, the most fascinating thing about Dr. Jha is that he simplifies the learning process. And I have always enjoyed attending his class. He makes it fun, he makes it interesting, and he really gets you to the foundation from where everything else can be built upon. So please close your other mobile phones if you have them on. Attend this class as if you were an IITian and enjoy the process. Over to you, Dr. Jha.
Yeah, very good afternoon and welcome to this class on industrial IoT. And before I start the session, immediately I got a chat question. So I just want to clarify that this is a repeat of the previous session, which was conducted earlier, same masterclass on overview of industrial IoT. So those who have already attended this class, I don't see that they should go through it again. But if for the revision they want to sit through, that is okay. But otherwise, it's already been done and covered. Because some of the attendees have not done this class earlier, and we want to touch upon all the fundamental areas of smart manufacturing. So I am just going to repeat the same session, which was on overview of industrial IoT conducted in August. So I think that's what I just want to clarify. So those who want to sit through, it's okay. But if you have already attended, I think most of the slides you have gone through and you have seen the subject, and you can opt to exit out of this. But others, those who have not attended, I think it's a very important topic that we are going to discuss today. And the subject is on industrial IoT, which is a backbone of smart manufacturing or industry 4.0 we keep on discussing. The subject is least understood. That is what I just want to emphasize on the details of the subject in depth little bit, so that you will get acquainted with the terminologies, at least when we talk about industrial IoT. It should not be carried away with other terminologies and understanding. So that's how the subject, I'm just trying to strengthening that understanding on industrial IoT today. So as has been briefed by Mr. Anup Wadhwa, this is what we are conducting this series of the webinars, and we also look forward some kind of a deep technology intensive trainings also as a part of this foundation which we set up 2 years back, that is IITD-AIA Foundation for Smart Manufacturing. And we have created an infrastructure as a common engineering facility at IIT Delhi under the bigger mission of Government of India, Department of Heavy Industries, that is the Samarth Udyog. So we'll be running through these series just to make you aware about these basic elements of the technology, and certainly later on you will be prepared more to do the projects in the same domain and implementations. So as was explained, we are taking this master class series on the 3 levels. The first level, we are still running into the first level of awareness, where we will be engaging you and sharing our thoughts on the typical areas or the subject technologies. And post that, we are also trying to engage you to some extent on the e-learning platform. So we have done these courses. Overview of smart manufacturing has already been conducted twice earlier. An overview of industrial Internet of Things has been done once, and overview of augmented reality in manufacturing has already been done. So these 3 awareness sessions we have conducted. Only some of you have missed basically industrial IoT session. So that is the reason we have planned today's session to repeat this industrial IoT one, because that's very important technology to understand. And subsequently, we will be taking another awareness session is on machine learning in manufacturing, and that is on 14th October that I will mention towards the end also. So with this 4 awareness sessions, I assume that all of you will be prepared at least with the basic understanding about the technologies, and will be ready to take a little deeper dive in experimenting with these technologies, because right now most of the time you will be just hearing what I'm just sharing with you, and may not be having that much resources to experiment on, and you don't even know how to go about this implementation part. So in this case, we will be taking you to the next level of learning, which is more on the implementation of these technologies, and there will be more hands-on one-to-one sessions where we'll be elaborating more on the steps to be implemented, and what all technology options to be played around. Because in these technologies, unless you do hands-on learning, it will just remain superficial, and you may not be able to absorb and then implement any of these options. So we will be subsequently conducting longer sessions with hands-on and project-oriented learning in the upcoming sessions, which are planned after this awareness one. And after you complete the learning sessions, we want some of you should come out as an expert in the domain of smart manufacturing, where we will be taking you along with a more in-depth understanding about these technologies, and little experimentation on the live projects actually. So that is the idea of having these masterclass series. So it should not be just limited to awareness. Those who have a keen interest into the subject should go along with us, and then we look forward that some of you will be moving towards the learning and expert sessions. So this is what the, this is 25th September. So this is what we are doing right now. And 14th October is the overview of machine learning. And then we planned an implementation session, that is the learning session, on 3rd of October. So after today's session and overview on industrial IoT, we are going to conduct an in-depth session, which is shortly coming up in first week of October itself. So those who want that, they can and absorb, and they would like to go to the next level, they can join this program as well. The mode, because for those who are joining new in this course, otherwise this is what we are trying to adopt right now. But most of the time in these 2 hours, we are interacting on these live sessions only, and we are trying to enroll some of you onto this e-learning for some of the exercises to be done over there. We are trying to take you onto this platform in slow manner, and we will be conducting few live demonstration as well as the hands-on. So this hands-on labs and some of the demonstrations certainly will be coming out more deeper into the learning sessions, and certainly this 3rd October session on industrial IoT will give you enough opportunity to do a little bit hands-on learning on the subject of IoT. And we will also be defining some course project in that. So that is what the plan. And as you all know, those who have attended previous sessions, we have live quizzes, as well as we will be conducting some kind of an evaluation onto the platform also. So that is what the approach of blended learning we are adopting while taking up these courses. So this is what the e-learning platform. I think most of you are now able to register onto this. Now I have enabled that if you have lost your password, if you forgot your username, you are now able to retrieve yourself. You may not to reach to me for those things. So that has been now enabled in this case. So I think after the sessions, we will be only enrollment part is left out on us. So once you are registered onto the platform, as you keep doing the sessions along with us, we will be enrolling you on those respective courses. So today's session is on industrial IoT. So after this session, I will enroll some of you who wants to take along in this journey. Now, just quickly explain the process, how you can self-register yourself. Now, earlier I was just announcing the creation of your user account at my side. So now onward, we have enabled that you can create all your accounts on your own. So once you go to this FSM Skills login page, those who have not, so this is required one time, because if you have done, if you have registered for any of the course earlier, you need not to repeat this process. Only for those new users, those who want to go along in this learning and they have just joined today this session, they can register for this platform also. So there's an option to create a new account. You can just click that, and then there's a form appearing there. So only thing you need to take care here, that you should use the username, the same email ID with which you have registered today. So that's what I just give you a sample. So keep your username as your user ID, as your email ID, which you have used to register, because I will be using the database who have attended today's webinar to enroll into the course. So if there's any mismatch into the user ID, certainly you may not be enrolled into the course. So just take care of that part. Rest of the things you can fill and you can register your account yourself. You can create your account. So once your account is created, at least you get an access to the platform, and then I will be enrolling you into the courses. So then that's what enrollment part is now controlled at our side. So we will be enrolling you in overview of industrial IoT. Some of the requests are still pending with me, so I will be enrolling for the other courses which you have attended actually. And certainly every one of you should be attending this or enrolling for this overview of smart manufacturing, because that's a basic fundamental course, and we are taking some of these topics in detail in these subsequent overview courses. So these are the 2 courses that of course you should go through this kind of. So we will be just filtering out the email IDs, those who are attending the webinars, and then enrolling them into these courses. So this registration part is now straightforward. You can do yourself. Only enrollment in the course is what we are controlling at our side. Now today's session outline, I will just brief you what we are going to discuss on industrial IoT. Certainly we will be starting with a quick quiz. Then I will give you a brief introduction about the subject. What's industrial IoT? What are the core technologies involved? What could be the possible business models with new technologies? What could be the benefits to the business? So that's a basic introduction I will be starting with. Then I will be taking you a little deeper onto the IIoT reference architecture, because it's very important to understand how the connectivity being established and how the individual level of networking can be done. So this 3-tier architecture proposed by industry consortium that I will be discussing. Then we will also be discussing on designing industrial internet systems. Naman, if you are there, can you just see the options to disable the hand raise, if that can be done? Because I will not be able to attend any of the hand raise activity right now. Please post your queries onto the chat as well as on the Q&A, which I will see later on, because I cannot pay attention to both the things. So once I finish my session, I will take up those queries towards the end.
As you did, sir.
Yeah. So just do that. So now we will be discussing after that the designing of the industrial internet systems. So what technology and protocol should be used. Then different type of networks involved, different layers of the networks there that I will be discussing, how the protocols will be working and what kind of an interfacing you are required to do. So there are different protocols working at a different translation communication level, and then middleware transport protocols that I will be briefing you on to them. Also, while we are implementing the pattern, so some of you who have done experiment on IIoT, they have some understanding about those protocols, but where exactly they fit into the complete architecture of IIoT, that is what I'm going to discuss and share with you. So real-time detection and reaction is very important for the all automation applications. So how that has been handled at the software level, so that I will be discussing. Then we will be discussing about the software design concepts, because once you get the data into the platform, how you will be building the applications, because towards the business intelligence and business logic, you will be interfacing the data with them. So that is what you can do. Then I will be discussing the IIoT platform architecture. In fact, we will also be discussing why there's a need of the platform, what could be the alternative means to implement IIoT even without platform implementation. So that part we will be discussing after this. Then I will just give you a quick glimpse on the different IIoT platforms, because today's session I will be just introducing you to the open source and commercial IIoT platforms. And then subsequently, when we take the hands-on sessions, we will allow you to experiment on these individual platforms, and we will guide you how to do the implementation on these IIoT platforms. So this is the plan for today's session. So we will be just starting with the quiz today, and that's the starting point. So quiz, I will be again running through the polls in this Zoom webinar. That is the mode I will be preferring, because that requires only one device to be used. So what I will do, I will just show you the question on the screen, and then through that you will be then selecting the answer through the poll window that is appearing onto your window. And then once I see the enough responses received, I will move to the next question. So that is just in a pre-course assessment about your understanding on the subject of IIoT. That is the idea here. So I think let's start on this. So the first quiz on the screen is basically identification of the different type of input output modules. So those who are planning to do any kind of an implementation of IIoT, we need to understand what type of signal you are going to capture and what kind of an output your control system is generating. So this is a very simple question. I will be just throwing the poll over here. So in that case, you have to match the type of A, B, C, D. There are 4 different type of modules into this PLC, and there are 4 different type of devices that has been shown, which are supposed to be connected to each of these A, B, C, D modules. So you need to identify. So for the understanding, I'm just elaborating on these acronyms being used. DI stands for the digital input, AI stands for the analog input, DO stands for digital output, and AO stands for analog output. So these are the 4 different type of modules being highlighted here, and the 4 different type of devices being shown over here. So you have to match what type of module A should be to interface this particular device. So I'm just launching the poll onto your screen now. So quickly identify this and take your time in responding to this question. Am I clearly audible? Because I see some of the messages regarding the volume is less. Can it be increased? Naman, can you give me the feedback on this?
Sir, the volume is well enough to hear. There
Okay.
is no issue. Already communicated.
Okay, fine. Fine. That's okay. Good. I think so. I have received quite a good responses by now. See, please understand this is a very basic thing to be understood before you pitch in any of the upcoming sessions on smart manufacturing, because the sensing is the first thing to start with, sensing and actuator, as I will explain you in the coming slides also. So please build up your understanding about these type of interfacing, uh, because without that there is nothing going to work. If you are not able to address this question properly, if you are not able to answer this question, please brush up your automation basics, at least, or the basics of the PLC or the controller, so that you will understand sensors and actuators first of all. And then beyond that, you should also understand the type of signals that you are getting from this. Because I see there are a lot of responses received which are not in line, which was expected. So I will suggest that please have that kind of an understanding build up before we discuss the topic. So I have already received 63% responses. I will request others should also participate, because those who really planning to take this journey forward along with us towards the learning sessions and the expert sessions, these quiz responses are very much important. If you are not attempting, certainly you will not be interested. So we will be reviewing these quiz responses, and before we enroll you into these courses further. So please participate in the quiz so that I will get that feedback that you are interested. Otherwise, you are just sitting into the seminar for hearing, that is fine. So those who have not responded, please try to respond, because that's very important for taking you along with us in this learning process of smart manufacturing. So I have already received response. I will show you. So I'm just ending the poll now, and I will show you the results actually. So I found that only 50% of you are able to respond correctly. This identification of IOs is only being identified correctly by 50% of the audience. So that's a very important point I'm just trying to highlight over here. Nothing wrong here. If you are not able to get the understanding of this interfacing, please spend some time from a standard textbook or literature. It will be available. Please build that understanding before we continue with these kind of sessions further. So the correct answer, if you see over here, is the B, and that is what has been responded by 50% of you. Rest of you have responded incorrectly in this question. So let's move to the next question now. So the next question is, so because IoT has its implementation in various fields, in this case, you see there would be the consumer IoT, commercial IoT, enterprise IoT. Certainly depending, the technology more or less remains same, but the domain where you are applying this IoT defines the different areas over here. And the certainly some selection of the technology components also important, because where it is too much critical and time sensitive, we will be opting different options over here. So this implementing IoT in healthcare is an example of what type of IoT implementation. So that's a question over here. I'm just throwing the questions for your response now. Please respond to this question quickly. This is to be responded much faster than the previous question. So when it comes to the defining the type of IoT and the sector where it is being applied, as I mentioned, the criticality of the information and the sensitivity in terms of the time, actually, it's very important over here. So we just not look from the user perspective, because we are right now discussing the technology part of this. So we should be very careful in responding, and we should understand these domain of IoT implementations. Good. So I got enough responses to respond to stop over here, and this is what the result on the screen. So now if you see that we have not looked into as an engineer, we have looked onto as a user actually, because we understand that healthcare is basically to reach to the mass. That is true. But when we try to look into the implementation of the technology, healthcare is coming under the industrial IoT. So I will explain that part. As I mentioned that the information is critical and time sensitive. So that is what is very much important to put the healthcare into the industrial IoT. So we'll go to the next question now. So now there are two things over here we will be discussing in the slide also. Machine-to-machine communication is one set of the technology which is already being in existence from last many decades. And today we are talking about the industrial IoT. So you need to identify what is actually the differentiator over here, which technology differentiate the industrial IoT from a machine-to-machine communication. So in that case, I'm throwing the question onto your screen now. So sensors and actuators, wireless networks, data analysis and visualization, or the cloud connectivity, which is the key technology differentiator between the machine-to-machine communication and industrial IoT. Please pay attention, because if you see, we are hearing a lot about industrial IoT in last decade only. But if you are responding to the sensors and actuators, certainly then you are not understanding the whole industrial revolutions at all. Even you have not understood the industrial revolution 3, and we are right now talking about the industrial revolution 4. Sensors and actuators are very primitive elements already in existence. So please be careful while you are responding to the questions. These are the different options over here. I'm happy that most of you have identified it correctly. So I think let me just stop the poll over here and show you the result. This is what the response that has been received. I'm happy that 45% of you have responded correctly. The answer is the cloud connectivity. You get confused with the data analysis and visualization. So the technologies are already available to visualize the data. So that is not get changed much actually over here. And certainly the sensors and actuators and the communication networks are already in existence before this also. So that's the reason that this cloud connectivity is the key technology differentiator over here when we talk about the industrial IoT. Let's go to the next questions in the quiz. Here there is an implementation shown over here, which is similar to kind of an implementation you have heard or you have seen through. So if you see here, there's a gas sensor over here. It's being interfaced with an Arduino Uno, that is in a microcontroller board over here. Wi-Fi module has been used, and then it has been connected to the cloud, which is in a ThinkSpeak platform, and get the information on the mobile phones. So this is one technology implementation. You need to just find out what exactly is being implemented over here. So let me just throw the question to you. Options are already being seen by you now. So is this a machine-to-machine communication, or it's an industrial IoT example, or it's an Internet of Things example, or it's just a simple industrial automation project being done? So the two confusing options over here, I think that's well understood by you. So that's why I am seeing that most of the responses are coming on to these two options. So once you go through this course, you will be able to make distinction, means where exactly the difference lies. And that is a very important point that this kind of a session is going to help you understand nuts and bolts of these technologies. So many times we take a different impression of the technology before we implement on this. So I have received the responses. I'm just stopping the poll right now. And I'm then sharing the results before I show the correct answer. So again, it has been correctly identified. It's an Internet of Things application. So where exactly is the difference when we talk about the industrial IoT, which is again the closest option responded over here. So the confusion was with IoT or industrial IoT, where exactly is the difference? So that's what this session will help you in understanding the difference. So if you have not responded correctly, it's okay. But if you have not responded at all, I think that is not okay. So please, if you are sitting in the seminar or in this webinar, please respond what you understand, because it's not just for any evaluation. At least I want to see that whether you are serious to learn about the topic or not. So the correct answer is Internet of Things for this question. So I'll just stop sharing the response to you. The next question on the screen is, so this is little bit more on the implementation side. Those who have done some kind of an experiment may be in a better position to respond to this question. So I'm just throwing the question to on your screen. So protocol used to communicate data from machine to IoT cloud. So I think that's a question over here. We have heard a lot about the cloud services available for IoT, either from Amazon or Azure or IBM. There are many platforms available today, and whenever we plan to implement IoT, we certainly look forward for certain platform where we will be pushing our data. But those who have experimented, they understand that the data coming from the industrial controllers is not as it is being pushed to the cloud. So I'm just giving you enough hint to respond to this question. So you need to find out which protocol is being used to communicate the data to the cloud. And so later on, we will understand how to make this data available for communication to the cloud. So from the received responses, I see some of the responses coming over here. So now if you see the distinction in the options over here, there are industrial communication protocols that has been mentioned. And there's a one protocol which is making a distinction over here, which is more towards implementation for IoT communication. I think that's a very important point to be understood over here. And I will explain in my session why this protocol is different from the other protocols we used over here. So I will end the poll over here, and then you see the result are with you here. As I was mentioning this, so there are three protocols which are industrial communication protocols over here. So Profibus, OPC UA, and Ethernet IP. The only protocol which is not industrial communication protocol, but it is very much required for IIoT implementation, and that is an MQTT. So 39% of you have responded correctly. MQTT is the protocol. We will explain and discuss with you what exactly this protocol is and why it is required, why it is so popular in implementing IoT, why we cannot push the data directly from OPC UA to the cloud, and why Ethernet IP cannot be used. I think those are the questions that are to be responded as we go along in this session. So the correct answer was MQTT over here. So this is the last question for today's quiz. It describe about one protocol over here. The short distance bidirectional digital point-to-point. I think each term have its own intensive meaning over here. Wired or wireless industrial communication networking standard, which is used for communicating digital sensors and actuators to either a type of industrial field bus or type of industrial Ethernet. So if you see here, we have sensors over here, and then there's an interface which is being used to get connected with the PLC. That's what the industrial Ethernet comes through the Ethernet switch over here, or any industrial field bus, which is directly communicating with the controllers. So you need to respond to this question. I'm just showing the question on your screen now. So please respond to this question now. So I'm again making suggestion that please participate based on your understanding. Certainly these codes are being made so that these things will be more clear to you. So there's no harm if you are responding incorrect. There's no problem, because that's why we are here to understand the subject. Good. So almost 70% of you have responded. I received the responses, and I'm happy that I think I am getting a correct response from majority for this question. And it's really nice because this is a little bit a new protocol that people are now implementing. And if you are aware of this, it's really wonderful. So the response that I would like to share with you for this question is IO link, and that's the correct answer for this question as well. Good, you have identified correctly. We'll move to the next, and that's the last question. Some of you have already heard about the IoT gateway, and we will understand why the gateway is required. But for those who are already familiar with this terminology of the IoT gateway, you need to identify what exactly which interface we cannot directly connect with the IoT gateway. So there are some interfaces mentioned over here. RS-232 is a serial interface, IO link, digital input, OPC UA. So you need to just find out which interface cannot be directly connected with the IoT gateway. So certainly this is in context with what is available today as IoT gateway. Maybe in future this would be incorporated also, but I'm just putting this question with reference to today's available technologies and the most popular IoT gateways. Good, I think you are responding quickly on this question, but I'm getting in a mix of response onto this. So no harm, because it varies from different type of IoT gateways also. Some of them have some features, but others may not have that. But one of the protocol is cannot be directly interfaced over here without you convert into the protocol that your gateway can understand. So I will just stop the poll for this question now and share the results with you. So RS-232 is the one that most of you have selected, but certainly these gateways has been designed to interface some of the hardware which is giving the serial data. So IoT gateway has provision of serial interfacing. It has a provision for the digital inputs. It has a provision for getting the data through OPC UA. So IO link you cannot directly connect with the IoT gateway. So unless you convert into a suitable industrial bus or the communication protocols. So that's the answer over here. Good, I think most of you have done nicely in the quiz part, and that reflect at least you have a lot of interest into the subject, and you are here to learn more about this subject. So that's my duty to give you more details on these technologies today. So let me go ahead with this discussion today. As we all understand, the terminology most popular is the Internet of Things. Now we all understood the importance of the Internet of Computers. That is what the terminology starts with. And earlier we all understand that the devices or the computers are basically get connected with the Internet. So Internet is evolved as a connectivity between the multiple computers. And as we grow into the network, this has been then converted into the Internet of Computers. And then as the technology changes and the hardware and the communication backbones are now available at a lower cost, we found that these kind of interfaces are now made available into individual things also. And that's how we call this technology that connect objects to the internet. So earlier we were connecting computers to the internet. Now we are connecting objects to the internet, and that's how the terminology Internet of Things is very popular. And depending on the type of objects we are connecting to the internet, that's how the different domains of the Internet of Things being evolved. And it's being heard in almost all kind of applications. But when we talk about the industrial Internet of Things, actually, we are specifically concerned about the industrial applications. So this innovation certainly playing a big role, and we look forward that some of the key industrial applications are evolving on the basis of this technology, and that's how the domain of industrial Internet of Things is a subset of IoT. Now let's come to this important slide to understand the different stages in the smart manufacturing implementation, because we are all taking the journey toward the smart manufacturing implementation and trying to understand the subject. So these are the different stages we have discussed in detail on the overview of the smart manufacturing course. But right now I just want to bring out that part, that sensing, computing and actuation, as well as the connectivity. These are the two prerequisites to start implementing any of the smart manufacturing project. So the advantages that we can see, the benefits that we can see coming out in terms of visibility, transparency, predictive capacity, adaptability, these are the more higher goals, I should say, that we can be achieved once we met the requirements for the first two blocks, which are very important to be understood in this case. And we are discussing one of the important block over here, that is the connectivity. So we'll just understand why the connectivity is important, and we assume that the sensing, computing, and actuation is already into the system. If not that, we have to enable the system with this fundamental requirements first, and then we will take the implementation of the smart manufacturing further. So preparing our whole system for the first two implementation is just making a prerequisite for the implementation of the smart manufacturing. So many times when we talk about implementing industrial IoT, we are not assuming ourselves as implementing in a smart manufacturing. We are preparing ourselves for the smart manufacturing implementation. That's the idea here. So this is one of the example, if you see over here, that's a industrial IoT implementation. So if you see that there's one factory that I just try to lay it out in symbolical way over here. There are different type of machines over here. So one, you have a conventional milling machine, then you have a grinding machine, you have a CNC control machines, there's a lathe machine, there's a horizontal milling machine. So there are different type of machines. That's what I think, if you are familiar with overview of smart manufacturing course, you are familiar with this gentleman, Samrat, who owns this kind of facility. And then he claimed that he has successfully implemented IIoT in his factory. So in that case, if you see that, what he has done, I'm just going to share with you, and then you understand. So sensors are certainly required to be connected in all these machines. So some of these machines coming equipped with the sensors in its initial manufacturing itself, but some of those machines don't have any such interfaces. Then you can retrofit those sensors. So it's the same way it has been done over here. And then you see here, there's some kind of a controller being used to interface this sensor, because sensor gave me analog output that I have to be captured at with some controller. And then he has used a popular communication interface, which is RS485, a serial communication interface. And he has connected all these machines through RS485 network, also pulled the data from this CNC controller on RS485. And then he put a converter over here, so which is RS485 to Ethernet, because today we are more talking about implementing everything onto the Ethernet backbone. So the same idea, he also had that, and he has implemented through a converter, which is converting the RS485 communication to Ethernet. And then subsequently, he installed some of the servers in his premises, which are capturing the data coming from these machines, putting the data into the database. He also implemented the visualizations and some kind of controls through the SCADA, maintaining the history of the data, and generate some notifications out of this data, whatever is being received and processed. And then, so visualization is now coming to him through this implementation. And then he also have an historian and notification being done over here. So I think those who are in the domain of implementation of this kind of a project, they can respond well to this question. So I just want to ask you on this question also. So this implementation, what Mr. Samrat has done, you have to just respond to this poll. What exactly he has implemented with this? So he has done an IoT project. He has done an industrial IoT project. He has done a machine-to-machine communication project, or he has done a SCADA project. So if you understand the subject a little bit, I think you are in a position to respond to this question. And if you don't understand the industrial connectivity and the network and how it is being done, that's also fine. But this is just a poll to get your feedback, so that most of the time, whenever you talk about the industrial IoT implementation, you come across similar implementation being done by the people at a different level. So factories are having this kind of an implementation in place. And when we talk about the smart manufacturing or fourth industrial revolution, they said they have already done this 20-30 years back. So what's new that you are talking about today in industry 4.0, and certainly when we talk about the industrial IoT. So this is the one being responded. I just want to end the poll at this stage to share the results with you. So the point that majority of us understood this is an industrial IoT project being done, and then you agree with what Mr. Samrat is mentioning, that he has successfully implemented IIoT in his factory. So this is not certainly an industrial IoT project. There's a difference between an M2M project and a SCADA project. So certainly this is more close to the SCADA project. So those who have responded to this, I think they have responded correctly to this question. And M2M can be a prerequisite before you implement the SCADA. So that is what is being done over here. So that's a good feedback for me to understand. So I'm just trying to capture that there is a small hairline to understand the difference between the industrial IoT and then we are talking about the previous communication that has already been. And you may come across this kind of an dilemma every time you talk about the industrial IoT implementation. So for my understanding, I just want to have another quick feedback from your side. So what kind of an experience you have in implementing industrial IoT projects? So those who have done, this is just a quick questions to get a feedback to me. So this will reflect then to what extent I will be discussing in depth about this topic. So the options over here are that you have implemented an IoT project, the kind of an IoT project we have seen in the quiz. You have connected less than 10 machines to the cloud. This is one implementation some of you might have done. Implemented home automation projects. Certainly those who are students and academics and hobbyists, they normally tried out this kind of an implementation to experience the connectivity with the cloud and the services that they can get out of that. Then if you have really done implemented industrial IoT project with more than 10 machines, that is what the question is. Pilot is the one most of us have started doing pilot in the domain of industrial IoT with less than 5 machines. That is another learning over here. So I see some of the responses coming over here. You have understood IIoT well but not implemented any project. So that is the another option over here. There is no problem that as we go along, we understood IIoT also, and we'll certainly look forward what all technologies are required to implement the IoT project. So with this, I think only 60% has responded. So I'm not sure, because at least you will be falling in one of these categories. So if you are attending this webinar, you can at least give me an indication that what kind of a project you have done. So that will help us in guiding you further, miss what to do next. So I got enough responses. So I will just respond, just stop the poll over here, and the results are here that if I share the results, so majority comes that they don't have any IIoT experience. So it's fine, that at least that's what this course is designed for. From today's course, we will be taking you in little bit depth, means what exactly this project is supposed to do and how to handle them. And then probably in the coming sessions, we will at least dwell you into these technologies, how to do that also. So there is no problem. So for 52% basically have no IIoT experience, but some of you have already done some of the projects. And then some of you understood IIoT to some extent, but not implemented any project. So that is again an opportunity to engage with you, that how these projects can, because we are doing a lot of projects within our premises in our lab. At the same time, we are also planning to do quite a good implementation with the industry also. Fine, I think let's go ahead and try to understand this subject. So when we talk about the core technologies for industrial IoT, I think as such, we see that there's not much new happened. So those who are familiar with the automation that has already been done and which we are classifying now as an industrial revolution 3, most of these sensors and controllers and then actuators are already in place. So sensors and actuators, and to great extent, this machine-to-machine communication has already been established. And that's the reason that when we talk about industrial IoT, people are saying that they already done this kind of a project 20, 30 years back. They have already spent a lot of money integrating sensors, actuators, and then build the communication. And today they are able to visualize their data, and they are able to make sense out of this data and then generate notifications, or maybe able to take some kind of a control action onto the system again back. So as such, if you see that the core technologies which are required, and I should say the mother technologies which are required for industrial IoT is already there. and there's only a growth of these technologies in the last 1 decade. But the most important part that is required and that is missing over here, the connectivity to the internet, because that's the potential nobody has realized earlier. So why would connecting M to M? Because we call this an M2M architecture. When you have sensors and actuators, when you establish a machine-to-machine communication and you are fetching the data and storing the data for visualization or generating the notifications, you have already done the implementation of this, the basic architecture. But if you try to connect this architecture to the internet, what kind of value addition it can bring in? I think that's the domain that makes a difference over here. And when we talk about the industrial IoT, we look forward that what kind of an additional value addition. It's not just a technology that you say that you have connected it to the internet. No, what kind of a value that you can derive out of this connectivity is most important part to understand. So why would connecting M2M architecture to the internet provide with greater value? And that's a question coming over here, and we are trying to address that to some extent. And that's the where we talk about the industrial IoT domain. So the key the differentiator, I should say, the technology is basically the connectivity to the internet. And that's what we will be discussing this industrial IoT. So if you talk about industrial internet, I think that's a very important part, because it's going to be a little bit different from what the internet we are using and connecting with our computers. And we need to understand the difference also. So when we talk about the industrial internet, basically we are talking about getting the visibility and insight into the company's operation, different assets. So what we are doing basically the connectivity with the machines and sensors. We are also implementing the subsequent layer of softwares over here. If you see that we have some middleware there, we have software implemented, we have a cloud compute platform available, and we also designed a sufficient storage. Some may be on premises, some may be on the cloud. So what we exactly want to achieve through this? So let's talk about the business gains, because it's fine that you implemented some technology, but what kind of business gains are coming out of this implementation? Because then only you will be able to justify the cost that you are putting into this integration. So when we talk about the business gains, quickly I will just give you an idea that it will bring out the operational efficiency gains. So you will be certainly gaining an operational efficiency, that the way the operations are being done today, you will get a deeper insight through the connectivity and IoT, and you will be able to gain a lot on improving this efficiency, and which will accelerate the productivity. So once you get reduce the time that has been spent in operations, we will be able to find out the reasons for the downtime, variation in the quality. You will be certainly able to accelerate the productivity. You are also be able to reduce the unplanned downtime. That's very detrimental for any of the business, because the current machines, if you are able to find out some idea or information about the different wear and tear into the machines, the way it has to be maintained, and if you are able to prevent a single downtime, I think that's a very important aspect to those who are really into the business and into the industry. They appreciate this. If you are able to reduce the unplanned downtime, this will bring a lot of advantage to you. And then we also optimized and increase the efficiency of the system. So the way the processes are being operated, we can optimize by giving a closed loop feedback to the system also. And this will in turn maximize the profits for the business. So these are some of the blocks we need to understand. And that's how everybody is appreciating the field of IIoT, and they look forward that they need to implement this. But we need to also understand what kind of technologies are required, what are the building blocks required to that implementation. So as we understood that machine to machine and industrial IoT, these are the two key technologies which are now we are talking about. So over M to M, we are talking about connecting it to the internet, and we would like to convert this implementation into some of these business gains. And there it requires basically the scale of operation. So another feature, I should say, that make a big difference between the machine to machine communication implementation and industrial IoT implementation is the scale. The scale of operation is vastly different in industrial IoT. And that's how you can see that in Internet of Things also. When we are talking about implementation, we see that we are talking about 1,000, 10,000 lakhs of the devices to be connected to the network. Certainly, this was not the case when we are talking about the machine to machine. So when we choose the technologies for implementing industrial IoT, the scale of operation should always be kept in mind. Otherwise, you will just stuck up in implementing some of the basic pilot projects. You will not be able to scale up the implementation to all the devices and all machines in your facility. So the scale of operation is vastly different in M2M and industrial IoT. When we talk about the benefits, let's have a quick understanding on this, because unless we see the benefits in this implementation, we will not be getting excited to do some of the implementation. Certainly as a technologist, we always keen to learn these new technologies. But for a businessman, it's very important to understand the benefits coming out of this, because you need to justify the ROI of this investment. That's a return that you will get out of this investment. So there are various avenues of the cost saving. Once you implement IIoT, you will be able to minimize the energy usage, because now you will be monitoring energy usage very closely. So once you are able to monitor, even by implementing IIoT, we are able to find out the share of the energy taken up by individual product also. Means while manufacturing this particular product, how much energy is being consumed, because that kind of an insight is completely missing today. And as the machines keep on behaving anomaly, it's generating anomalous behavior, we can easily identify. And the idea is that once you are able to identify that kind of a variation, you can immediately take measures to control it. So you can save a lot by minimizing the energy usage. And that is only possible when you have first-hand insight into where the energy is being consumed. Integration with your supply chains, you will be able to save a lot, making the goods available at the right time. So you will be able to track where the goods are, where the raw materials are. So integration with the supply chain give you a more transparency and insight into programming, into basically scheduling your operations. You need to have few on-site personnel, because the machines today installed, they are sending their information on a periodic basis to you itself. So as an OEM, you will be getting all the information about the machine operating in any geographical region. So it may be within the country or maybe outside the country also. So then it requires a fewer on-site personnel. Only when you really diagnose the problem and you want to send physically to correct the problem which is not being rectified by the personnel present over there, then you need to mobilize your people. But certainly not to look into what's the reason for this problem, because many times if there is a problem in the machine, people just give you a call actually without understanding what exactly is the problem. So from a remote, at least you will be able to understand the nature of the problem before you mobilize your people to reach to the site. So that way you are able to save a lot. And I'm sure that the post-sales services is the most critical one that get affected by the implementation of IIoT. Because today's problem is that you have to deploy your on-site people. They keep running around the different customers basically to address these kind of issues. And then you can dedicate less time to the low level tasks. Some of these tasks can be automated to some extent. So every time you may not be making those low level decisions, because some of those usual decisions can be programmed into the system. So there are ample opportunities to save a cost depending on your usage, depending the kind of a scenario you are implementing this. You can plan to implement IoT and reap any of these cost benefits. Second thing, you can have the benefits in terms of smarter automation that you can do with the IIoT implementations. It means that you can auto-tune and optimize based on the feedback that you are receiving from the surroundings. Now your machine can basically do this kind of an auto-tuning and optimization based on the feedback that you are getting from other machines or other sensors. So that kind of a tuning can be done. Notification reporting for diagnosis and resolution can happen. That's how we call it a smarter automation, because now the machine is able to diagnose the problem. It will be able to communicate and also able to suggest you the resolutions. Very important slide, though it looked like keywords over here, but if you really understand the benefits, if you go into the depth of this, each of the pointer that has been displayed over here, I think they will be helping you in justifying the ROI. On-demand assembly driven by the business system. So certainly to bridge the demand and supply gap can be done with the help of this implementation. Another aspect that you get benefited is the visibility anytime and anywhere. And I think that's the major benefit every one of us see when we implement IIoT. Because if I need to get an insight about my operations sitting somewhere else, and most of the COVID days, we are looking forward for this immediate, I should say, the low hanging fruit to be encased while implementing the IIoT. Because right now we don't have a visibility what is going on in the factory, who is doing what operation is going on, which production is going on, which is lagging, which is on time. I think that kind of visibility is very important. So it will help us in making a better decisions. It will increase time to value. It will also increase the safety of the system and security. And remote asset monitoring and managing is another advantage you will get. Last one is basically the better customer services, because most of the car, let me give you a quick example, the machines and the automotive, that is going to affected a lot with the IIoT. And these days, if you see that even consumer IIoT is also picking up very fast, and the recent products being announced by the Apple and other companies. So the health is basically the more focus there. But if you see the kind of a services they are going to give based on this data, they will timely indicate if there is any changes in your health patterns that can be done. They can advise you to visit doctor or take some precautions. I think those are some of the common examples in the consumer market. But through the machines as well as the automotive car, for example, so you can get a better customer services. If I just put it here, predictive maintenance, remote troubleshooting and patching, product improvement based on customer care. Let me put a very good example, because that's one I have experienced in the new electric vehicles. Basically, if you have observed that the IIoT is coming inbuilt into these vehicles actually. And once I have, because one electric vehicle, the case that I've experienced that the battery was draining very fast, and I just called the customer care. This is the behavior of my car actually. Immediately they get access to the data of my car. I was not aware of earlier, but then later I realized that they are able to find out the reasons why this car battery is draining without even making a single person visiting me or seeing the car itself. Because this vehicle is now connected to the backend system, they are able to analyze the statistics, and remotely they have done some configuration into the vehicle actually. That's a wonderful part actually. So they have done some kind of changes in the parameters, and they said that now you monitor next 10 days and then come back to us. I think they have rectified the problem and by adjusting some of the parameters which are taking a lot of batteries actually. It's a wonderful experiment that I experienced, and that's the same way even when we talk about the services to the customer. If you can render this kind of services, they will be the happiest customer, get building more loyalty in your product actually. So I think a lot of opportunities over here where you can reap out of this IIoT implementations. So that's how, as a businessman, we always look forward for the increased profits, increased revenues, and low operational expenditures. That's what I was just trying to highlight in the previous slide as well. But if you see that when we talk about the simplest implementation and faster ROI kind of thing, predictive maintenance is certainly the one which can quickly give you the return. So those who are planning to do and implement it, because IIoT itself is just an enabler. If you see that, I have already mentioned in the stages that this is just a prerequisite for that. IIoT itself is not giving you this kind of an experience unless you take the implementation to the next level. So what I'm just saying that once you spend a lot in creating the infrastructure, building the connectivity, the advantage is not far away, because then it requires a lesser investment. And then if you talk about the predictive maintenance and the product quality monitoring, these are some of the quickest services through which you can justify the return on the investment here. Even some of you can think of a new strategy to your business, because that's a very important aspect over here. Instead of focusing on what a customer actually wants, instead of focusing on what exactly the product you are delivering. So instead of just focusing on your products actually, if you can more focus on what your customer wants actually, that's a kind of a new strategy can be bring out with the IIoT implementations. So you have to think out of the box also, because once you enable your systems with this kind of a connectivity, let's not just see it as a connectivity, let's not just see it as a data flow that is happening in the premises. You have to now imagine, and you have to be more creative in utilizing the value that is coming out of this data. And that's how it says that it can brought out a new strategy to your business as well. So let me just give you a quick idea about this new strategy. This is one just example where I just mentioned that there's an tire manufacturer and there's a logistic company. So if you talk about the kind of a transaction, the kind of business they used to have, we as a tire manufacturing, I'm always keen to sell the tires. That is what the mindset we have today. And as a logistic company, I have a resistance to buy these tires, because tire is not as such a value to me, because it's just a kind of a thing I have to do once it wear out. So I'm not adding much value to my services as such. So I'm always refraining myself to buy more tires. So I'm just trying to negotiate on the price for each tire. And every time there's always I should say there's a gap in doing the business. So that was the existing way that we always look forward the economy as an income economy. So the manufacturer always see there's selling a tire as an income to him, and the logistic company is always finding it's a difficult part for them. So this is not just a way we see the usual economy. So what the next out of the box thinking could be this, because we are more keen in getting the services. We are not fancy about the products actually, because we are more keen to get a services out of that product. So that's how this idea is being presented, that why I am interested in buying a bulb. I'm interested in getting a light. That is my requirement. That is my foremost requirement. So if you think that instead of selling a bulb, why can't the light be sold? So that's the idea, and that's what people call as an outcome economy. So instead of selling a bulb, I will be selling services in the form of light. So if I hire a services that my premises should be lit properly and my electricity bill should be reduced with this consumption. So I'm just taking this as a service. If the bulb is faulty, if the LED is faulty, if something is not working, I think that's the something else headache. I'm just interested that my illumination should be proper in my premises. That's a quick example over. So instead of worry about the wiring, the replacement of the bulbs, tube lights, or anything else, I'm more keen in paying for the services as a lighting. I think that's a more models, pay-per-use models are available today. And we call this an outcome economy, because outcome is where the customer is interested. He's not interested in your product actually. He is more interested in getting the services out of that product. So that is what is known as the outcome economy. And let's see that example over here. Same, the tire manufacturer and the logistic company. If you think through about this outcome economy, the example will be that I will be interested in getting services of the tire actually. I'm not interested in buying the tire. So there's a deal that has been announced by the manufacturer today, that you will only pay for the mileage and the wear. So I think that's the most happy day for the logistic company, because they are now no more worried about replacement of the tires in their fleet of 100 vehicles or more vehicles actually. I think that's a way. Now, if you see that with this, it's a good deal for the logistic company, but what's a good deal for a manufacturer over here? Because I think he's not going to get money immediately out of this. He's only rendering the services. He's investing his own money out of this. So certainly there should be more means that he should be able to give more services. Instead of just keep the vehicle running onto the road, he should also be able to render more services. So tire manufacturer should certainly be giving more services to the logistic company. I think that's a really value addition that can be visualized over here. And that's the reason that the tire manufacturer is not entering into just deal of the services. He in fact see the value that can be further sold to the logistic company. So if we can just monitor the driving pattern of the vehicle, he can even advise on some of those things, which will result in the low wear of the tires. I think those kind of additional services can also be think through in this outcome economy. So instead of this just services, if you see here, this manufacturer thought through to implement some sensors into the tire, which will help us in giving a services to the logistic company to inflate the tires at the right time. And he will also be monitoring the wear and tear, so that he will be able to bill the logistic company accordingly. And the logistic company is just paying for the tire wear, and then additional value added services that can be done on top of that. I think that is how the mobile or the telecom companies are getting advantage. Initially, they started with the communication business only, but now they keep on adding more value added services, because once their backbone is already working, everything is ready. you can top up with more services, and you can get a delta from the user or consumer, and that will add more value to you. So I think that kind of a thinking is adding more value once we think about the IIoT, because this kind of a sensor monitoring and then the value addition can be done only when we think about the IoT. Now, we can also have a quick look that what qualifies as a complete IIoT use case, because we cannot see that every idea is an IIoT use case, or what's the opportunity and what's the readiness to implement the IIoT project. So this is just one slide which gives an idea about the implementation of the IIoT use case. So you should be able to uniquely identify and connected things. Basically, that's very important. Means what data, which devices, which machines you are able to connect, and what data you are able to get. If you are uniquely able to identify those assets or those devices, those sensors, then this is the first requirement for this. For IIoT project, this is the first thing you should be able to do, that you should be able to identify and then connect these things. Then you will be able to capture the data and then contextualize and store the data, because that's another step which is important over here. If I am able to take out the data and then contextualize this, I can interpret the data in a particular context and would be able to use this data other than the storage also. Later I also want, please mind this, triggering some automated responses. If I'm not that keen in triggering the automated responses, certainly I will not be able to take advantage of this IIoT implementation. So we should always be concerned about this, that analytics should be there, which will trigger the automated responses. If you just end up into the second block, which is just a data capture, contextualization and storage, then it will not be in a complete IIoT use case. You should be able to implement the third block also. You should also see the value that is coming out of the implementation of this third block. And then you should also be able to measure the change in the performance. If you have done the project, if you have got the data, you have analyzed it, you have triggered the response, but you will not be able to see the big difference coming into your implementation. And you are not able to see the change in performance, then again it will not be a successful IIoT use case. So then these 4 blocks are very important, and for at least assessing any of the IIoT use case. Otherwise, towards the end of the implementation, we will arrive at the conclusion we have invested a lot, but we are not able to justify the investment in this case. So if you have these 4 blocks very clearly understood and able to see the potential of implementation of all these 4 blocks, then it makes a potential IIoT use case. Let me give a quick example over here. That's one use case is a return on assets. So when we have certain assets in the factory, and certainly the machines, I'm just taking an example, is one of the important asset over here. So once you have a machine as an asset, what I am supposed to do? So I will just start with it. I will be able to implement sensing into this machine. So I will be able to capture the temperature. I will be able to monitor the wear. I will be able to sense the vibration in the machine. I will be able to monitor the energy consumption. So this is the first level, that I will be able to sense some of the parameters, some of the data from this machine. Then this sensing will be further used to analyze the behavior. So this analysis is very important out of this data, what you are getting over here. So what exactly you are analyzing with this data? The maintenance history of this machine should be analyzed. The set specifications should be analyzed, that will be available to you. What is the remaining useful life? How much life has been used? That is being captured over here. Which part is replaced? What are the spares required for this? That kind of information is important. Availability of this resource, because depending on the downtime of this machine, the behavior of this machine, you will be able to analyze the availability of this machine. And then you can plan the usage schedule of this machine. I think that's a kind of an analysis that can happen in this case. And after this analysis, unless you intervene in the system, unless there is some feedback that will go back into the system and you will be able to take some corrective actions, again, this is important part. So some kind of an intervention should also be possible. So this is a philosophy of sensing, analyzing, and then intervening, and after that you will be learning out of this. So what kind of intervention you look forward, that there should be an operator's alert that can be generated. The scheduled inspection can be planned based on the analysis of this data that has been received. Parts can be ordered depending on when it is to be replaced and when the replacement is required. So based on the repair history and based on the data that it's going to fail, the system can order the parts. You can schedule maintenance properly. So these are the kind of an intervention that can be possible based on the information that you have received. You can change the production also, reroute of the production can also be done, and you will be able to update the records about the machine. So these are the kind of an interventions possible. And in due process, you will be learning basically in selecting the assets, because now in the next project, if you have to select some of the machines, you will be looking at this kind of an analysis, and you will be able to select the right asset for your operations. Maintenance planning can be done better. Operating conditions can be monitored through this kind of training on this equipment can be done, and then later on ROI can be justified. So this is what the quick example on the one of the example of the asset monitoring basically in this case. So this is another example I just want to quickly give you idea about. This is one of the machine that we are doing in our facility, the implementation of this IIoT in our facility. So this is a conventional machine, and if you see the values that we look forward out of this implementation is the product quality monitoring, machine health monitoring, and then there should be some guidance to the operator. So we have decided, because this is a completely conventional machine. So as you see the blocks that I have shown, you can start with the identification of the sensors and actuators to be implemented over here. And with the monitoring of the energy, and you need a controller and the connectivity part that can be done over here. And then you want a certain feedback to be given to the operator. So I think that's a way that you can assess your use cases as well. And we are already doing this kind of an implementation in one of our facility that we are building up as a cyber physical factory at IIT Delhi. Now let's talk about, so till now I have just briefed you about the basic ideas. It's just kind of an introduction about the IIoT. Now I will take a little bit deeper dive into the technology blocks required to do this. I think that's very important to understand. So again, I'm not taking into the programming and then little hardware details. I'm just giving you an overview, superficial overview, what kind of things are required. So when we talk about the IIoT reference architecture, that's very important when we are implementing the IIoT use case. So we have assets, we have machines available to us. So we call them things, because everything we are talking about is IIoT, and T is the term which signifies the things. So whether it's in a machine, whether it's in a sensor, whether it's an actuator, we nominate everything as a thing over here. So these are the things, and we have different applications. So from these things, I'm interacting with some of the applications in this case, and these applications are rendering some services. And if I have applications individually to these machines, and then they will be just giving me some information about these individual equipments, this kind of an implementation is what is M2M. So we will be establishing some kind of a communication between the machines, and the data will be taken into the application, and we will be able to exploit some services. When we talk about the IIoT, we will be just drawing this line. So similar infrastructure, things are there. Again, we have applications, but in that case, these applications are running onto the web. They are not just communicating directly into these assets. We will be giving more services through these web applications. So internet is the thing that is being added over here. So these machines are connected, the data is being taken into the internet, and then from there we will be giving the services. So this internet block or this web block is basically the key differentiator I keep on insisting since the previous slide. That makes the difference between IIoT here. So when we talk about the IIoT, as I was mentioning that there are different domains of application of Internet of Things. So consumer products, commercial environments, enterprises, industrial. So I think that applications are different. Consumers, as you have seen that the products where you will be adding these sensors and you will be monitoring those products is the consumer, and you will be rendering some services on top of that. Commercial one, you have this monitoring of the replenishment of the products, whatever is available on the shelves, You will be monitoring through the RFID tags, means how much is being consumed, how much is to be replenished again. So that kind of a consumer application, maybe in the retail also. Enterprise, you will be getting more information at the business level from this sensor integration. And then we are talking about the industrial IoT today. So industrial internet is basically found its more application in the energy sector, healthcare, transportation. So when we talk about the application of industrial internet in these areas, we call it an industrial internet of things. Now, when we talk about the industrial internet of things, let me just brief you a little bit about the systems. So we have industrial systems. So before we put this word internet in between, we need to understand what is there in the industrial systems. So when we talk about the industrial systems, we have sensors, we understood that, we have actuators there, we have controllers over there, we have networks. So this is what the industrial system exists. And certainly you have networks, so you will be communicating between these assets also. And that is where we call it an M2M. So this an interconnectivity connectivity between the different machines is also already being established. So once you have an industrial systems connected through this M2M implementation, now when we talk about the internet part, so that's what I'm just saying, we will be adding another piece of technology over here, which is an internet over here. How it makes a difference. So when we bring in the internet over here, we will be able to move the operational data to the internet, and from there we will be connecting back to the ERP, where it could be in a customer relationship management, maybe the supply chain, maybe the business intelligence. So I think this kind of a connectivity is being established. And once we bring out the internet, then we call it an industrial internet systems. So this is one side. If you see that industrial systems are there, and the usual protocols of the communications are already there existing when we talk about the M2M implementation. On top of that, if you are trying to take out the data from here to add more values, we will be taking this operational data to the internet and then get the ERP connected. So this will help us in doing advanced data processing and doing the cloud-based comparison, and then maybe running some predictive analytic algorithms over there. So this will bring out the more optimized decisions based on the data. So data-driven optimized decision making is being possible over here, and which will help us communicating back to improve the operational efficiencies. That is what we call as an industrial internet of things, or we call it industrial internet systems right now. So clear distinction I would like to bring out over here. We are talking about the industrial systems. And if we are connecting these industrial systems to the internet, we call it an industrial internet systems. And people see a lot of value coming out of this integration with the internet. And there's a consortium which defines all those standards, because then there should be a methodology how this connectivity to internet can be established. It's not so simple that you just connect your computer with Ethernet port and you will get connected to the internet. You will be start surfing the network and you will be able to get the data, whatever you want. Industrial internet systems are not so easy to connect with, and there are a lot of things to be understood, whether it's in a type of the data, the type of interfaces. So it's not just one Ethernet port or RJ45 available. You just plug in a cable and you will get the data out. So a lot of things to be understood, and that makes this domain of industrial IoT completely unique to be understood over here. I hope I am clear to this extent over here, and just trying to make things simple so that they can be understood at this level, which is just an overview part. We talk deep about these technologies when we go deep into this implementation of the IIoT. There you will really experience means what's the difference coming in, though it looks like a very simple block of internet being connected to the industrial systems. But really, when we try to implement this, I think that's a bigger hurdle and the bottleneck we all experience when we do this implementation. So there's a 3-tier architecture already been suggested by this IIC, that's an Industrial Internet Consortium, which suggests how this implementation can be done. And when we adopt this 3-tier architecture, we are able to do a scalable implementation. I'm again emphasizing on this word, scalable implementation. Certainly there are means possible without following this architecture. You can implement Internet of Things, you can shortcut many things, and you can push the data And I see a lot of experiments people are doing. They just connect one piece of the hardware to their machine controller, and because the services are available most of the time free of cost, also you can easily visualize the data onto the cloud, and you can see that this the different visualizations that can be done, dashboards can be prepared, and we see that we have done the IIoT implementation. But certainly when it comes to the value that you can extract out of this complete IIoT and how it can be made scalable, this architecture is very important over here. So let me just explain this architecture to you. So what we have at the lower level of the architecture are certainly the machines, and that is what we call things in the industrial or industrial IoT terminology. So these things could be a CNC machine, could be your AGV, that is the mobile robot. It could be your articulated robot. It could be your conventional machine. So there could be anything that you would like to connect on this IoT platform. So now those who have understood this, the interfaces, and depending on the type of controllers you have. So this CNC machines may be running on a Siemens or the Fanuc controller or a Mitsubishi controller. Your AGV will be using a single board industrial computer there. Your robot will be having a robot controller, which will be again interfacing, have a different kind of interfaces, and conventional machines have no interface. So you need to add an interface to that. So this kind of a heterogeneity you will always see when we talk about the industry, because normal Internet of Things you see or Internet of Computers, you will see that there are all similar hardware on the other side. You have all computers on the other side. You have all microcontrollers on the other side. Now, only thing that you see here, every machine has a different physical interface, and every machine has different communication interface actually. I think that's a wonderful things to handle when we talk about the industrial IoT. So these blue circles, what I have drawn is basically the AND nodes. I will call this an AND nodes. This AND node is representing some interface with each machine. So we need to identify what could be that AND node hardware, and how we can establish these AND nodes which will communicate with the machines which are different on the other side, and we would like to bring out the data on the other side. So what our idea is that we would like to bring all the data from this heterogeneous hardware in one language basically, and that is what we want. This gateway is being placed over here, and this gateway is able to communicate between these AND nodes. Please understand this block very carefully, because each level of connectivity, each level of hardware is very important and crucial here. So in this case, what I have done, these blue blocks, I have identified what could be that piece of hardware or software required, so that I will be able to bring out the data at the edge here. So this is the premises. I can see this could be a shop floor, or this could be one manufacturing cell from where I would like to bring the data in a common protocol over here. And this we call basically a proximity network. So the network that I'm going to build locally, that the network that I'm going to create locally between these machines, and which is the most important part, the same way we have done the machine-to-machine communication. In that case, I would like to bring all that data to my edge gateway, because from here only, why this is gateway, because from this proximity network, I will be taking this data forward for further processing and the decision making. And this is the physical layer where we need to implement a lot of things, and we call it an edge tier. So edge tier is somewhere sitting in your shop floor, and it could be one shop, it could be one factory, it could be the multiple factories at a different geographical locations. That is what the edge tier is. And you see that you have seen the heterogeneity over here. The purpose of this edge tier is to get the data collected from these individual equipments, and then aggregate this data, put this data together, and then transmit further for the monitoring and control functions. So that is the key part. And most of the difficulties that we experience today is in creating this proximity network, and how this network can be made more scalable and to address different type of hardware. Now from there we have, so once we get the data aggregated at the edge gateway level, we would like to bring out more values, and we need to process that data. So that is where the service platform lies, and we call it a platform tier. We would like to pre-process this data, transform this data to get a meaningful insight out of this. We would like to run analytics on this data that is being received, and we would also like to store this data. So then this could be another layer over here, another tier over here, where we would like to exchange the data from the proximity network, and we would like to bring out this data for the processing, as well as to generate some kind of a control signal back to the physical hardware. So this layer of communication we need to use is known as access network. So the network that will make your edge gateway connected to the service platform is very important over here. And we will see in the coming slide what kind of a network is required over here. And this we call this a platform tier. So when we say platform, certainly it would be a combination of hardware and software that is to be placed, and that will be communicating back to your physical machines on the shop floor. So this platform is responsible for data processing, analytics, and the storage, or maybe some more decision making happens over here. Beyond that, now this platform is doing all this processing, and again we make the outcome available at the platform level, but we also look forward for the business level. So where we will be having the applications running. So data itself is not the application, because we would like to render some services to the user. So that's a third level or third tier over here is the domain applications. That there could be in the mobile apps, there could be web apps, there could be a notification services. So your rules and controls will be running over here. So kind of an if this and that. So what should be done if this is the behavior of the data, if this is the outcome of the analytics, what should be done after that? So we call it an enterprise tier, where most of your business logic resides for the decision support system. The most important thing I would like to mention over here, again, we need a different network to be connected between the platform and an enterprise tier. And this is what we call a service network. Now these three blocks, the technology to be used at these three blocks are completely different. And the kind of a network and connectivity required to connect these individual tiers is also different. If you understand these three blocks clearly, I'm sure that you will be able to scale up your any of the IIoT implementation to the bigger extent. So let me quickly elaborate on the detailed part of this. So when we talk about designing the industrial internet systems, which is something which I was mentioning, which I've shown the block over here. In this case, we are talking about the core M2M or IoT technologies in terms of the sensing and actuators, and we try to establish the connectivity part over here. The choice of the communication technology is very important over here, because now you are physically connecting your assets for the next level of processing. And on top of that, you will be able to realize the benefits. So choice of communication technology will affect the cost part, reliability, and the performance of the device interconnecting systems. So there are multiple options available at this level, and as a technologist, we should be able to advise based on our understanding how to choose those different options at this stage. So when I talk about the proximity network, as I was mentioning earlier also, the heterogeneity of the interfaces that you can see here. And you see that some of the machines are having a serial port. It's a 9-pin D connector over here. Some machines will be having an Ethernet connector over here. Some machine will be having a wireless connectivity, possible in the form of a Bluetooth communication. Some machines will be having a Zigbee communication available onto that. So you see that these AND nodes have a variety of communications available. And from there, you have to aggregate the data. I think now you need to find out. So it's almost like that one computer will be coming out with a DB9 connector, another is coming out with a 3-pin connector, another will be coming out with an USB connector, another will be coming out with a even RJ45 connector. And you are supposed to bring out the data from all these devices. So this representation of proximity network is almost similar to that. I think that's a very practical thing you will experience when you go deep in implementation of this technology. And from there, you have to take the data out, because beyond this, we would like to have the data, means data. It would be either a string, it would be either a numerical value that is coming out, it could be in a binary representation of some state. So at the processing level, at the analysis level, I'm just interested in that certain values only. How that being taken and transmitted to the platform level is something the responsibility of this edge tier. So you have wired or wireless options available in the physical layer. You have a low power device requirement because some of these are the mobile devices, some of them are the wireless sensors over here. So what technology and protocol should be used? I think that's an important aspect to be addressed when we talk about the industrial Internet of Things. Now, the interesting part is the legacy industrial protocols. I think we always see this as a bottleneck and hurdle for this implementation. But let's try to understand this is not the hurdle. It is the way the technology has been evolved, and it's a way the technology has been developed. I think that's how we are experiencing this. So it's almost like that we are getting the old people as a legacy available to us, means what to do with them. So anyway, we have to live with them. So we need to find out the way of communicating and interfacing with them. I think that's the same thing is applicable to industrial protocols also. And they have been evolved over a period of time with certain things kept in a mind. So many industrial technologies are implemented with the life cycle of 20 years. So anything you are coining, if you are developing something, you're talking about the industrial IoT today, the kind of interfaces and the protocols you're talking about it, we always look forward and a bigger lifespan here. Same has happened with the previous technologies also. So whether it's an industrial, whether it's an RS-232, whether it's a Modbus, whether it's a Profibus, RS-485. So all these field buses basically developed over a period of time, and that is being developed by different group of people considering this lifespan of 20 years. So that's how we get all that legacy available to us. And now we are talking about the unified language. Now we were talking about the data should come in a unified format. So we have many legacy technologies in place. You cannot get rid of that. So assumption should be right. We should not assume that all of my machines will be having an Ethernet port and connectivity, and then I will be easily implementing all IIoT projects. So this assumption is wrong. Why I'm mentioning this? Because the way it has been developed is nothing wrong in that way. So we will have all these legacy technologies available with this, and ancient communication protocol is still active in the industrial. That's why I'm saying in the ancient communication protocols, because these technologies are still available, though they are very old. When I talk about the serial communication, I think easily more than 40, 50 years or even older than that. But still you will find some of those controllers are having serial communication only. You have that serial port available onto these boxes. So then ancient communication protocols still available. They will be active in the industry environment. So we need to deal with them. So as I say, these are some of the ancient communication protocols, RS-232 serial communication. Many times we have this 4 to 20 milliampere current loop available. So some of the sensors are directly giving me the inputs in this format. So they are slow, but they are reliable analog technologies. Means the signals are being transmitted in an analog form. That's how we call this an analog technologies. But they are still reliable and working from last many decades. There is nothing wrong with them. People are still relying on the data that is coming out of them. So on one side, you have this ancient communication protocol. Other side, you have field bus technologies evolved because now people migrated towards the digital communication controls, digital communication protocols. So a lot of field bus technologies being evolved. So maybe EtherCAT, Profibus, DeviceNet, ControlNet, Modbus. So as you deal more with the industrial communication protocols, you will certainly come across these kind of communication protocols being implemented. And they have been implemented at the different layers of the OSI model. And that's another aspect to be understood. So field bus communication technologies, most of them have been designed or they have been evolved. So interoperability never being taken as a concern. So interoperability is never an option basically while developing these technologies. And now we are finding a problem. Now we are experiencing a lot of problem in connecting with these technologies. So that's the point I just want to make over here. So modern communication protocols, where we are talking about these communication protocols are the industrial Ethernet. We want everything to be brought onto the Ethernet, and there's a certain latency requirements and the reliability requirement. We call it's an industrial Ethernet protocol, which is supposed to work safely on 100 millisecond kind of a latency time. Now these communication protocols are further enhanced by the encapsulation of these field bus technologies. For example, this Profibus is further encapsulated with the industrial Ethernet. We call it a Profinet. So that's a way that these protocols, these technologies, which are earlier available and evolved with the proprietary communications, now being brought into the Ethernet domain, and certainly the latency has been improved over here with a 20 millisecond kind of a delay that you can do here. But we are further looking ahead in terms of the time scale over here. We look forward that there should be a signal that we want to receive, or the information that we want to process in the scale of 5 to 10 millisecond, maybe 1 millisecond, and even less than 1 millisecond actually. So people have designed different means of communication on industrial Ethernet itself. There would be different communication channels operating onto the same physical layer. Sometimes it's the same physical layer, sometimes even some of those changes can be done. So we'll see that when we talk about the 5 to 10 millisecond of data, we will be talking about most of the application data. So we need to make a distinction between the type of data that you want to communicate over here. So application protocols and the application data can easily live with a 5 to 10 millisecond of a delay. We are talking about non-critical time-sensitive data or the non-critical time-sensitive traffic that we are talking about 1 millisecond kind of a thing. So there we will be prioritizing some of these packets. So again, the physical layer will remain same. We will be implementing some kind of an application protocol which we will be filtering, which is at the more priority packet that can be delivered at fast. So this can be easily done by prioritization of the implementation. Then we talk about the 0.2 millisecond of latency, which is certainly useful for the critical time sensitive data. And there you need to overall little bit on the hardware side as well. So we need to implement an Ethernet switching, which is going to be in a gigabits per second kind of a magnitude. So that's a way the different channel of communication built over the same industrial Ethernet for the different time latency requirements. And that is already being now implemented, is made available. Now let's quickly talk about the gateways, the role of the gateways, because on one side we have seen the heterogeneity of the network, and other side we look forward for the industrial Ethernet. So we are talking about the IP backbone. So all our communication, all our data flow on this IP backbone. So that is the way you require a gateway that is on a hardware, which is physical hardware, which will be capturing the data in different protocols over here. So you may have different interfaces available, maybe either in the protocol level or maybe in the physical level itself. So you may have a provision to interface serially. Maybe some of the gateways may give you interface for interfacing digital IOs also directly onto the gateway. So you will be able to monitor those things. And you can program these gateways. So these are the, again, programmable devices. You can program these gateways for different protocol exchange, or many times these gateways are capable of generating notifications themselves also. And they are coming as a very handy device in implementing industrial IoT. I think that's good. So a single piece of hardware solves a lot of problem on the heterogeneity of the communication over here. And then there's another way to handle this is through the data aggregator. So instead of a physical hardware, you can have some kind of a software which will be converting the protocols from one protocol to another protocol, and making more protocols which are more web friendly available for the implementation different applications over here. So that's what I'm not going into the detail, but this is a data aggregator, which is a capware here, which I can mention. So this is again a way that you can build an interface between the web technologies and other side the industrial communication technologies over here. Then there are different layers of the communications that are required. So I'm just a little bit touching on them, not going into the detail, because this access network is again an IP network, because it's a simple IT network on which your compute systems are also connected. So this access network is an IP network, which will be just getting all the data from over here and then pushing the data to the platform. So if you just plug in Ethernet cable to your IoT gateway and then you plug the data to the platform which is coming on Ethernet, you will be able to do the job of this access network. So your traditional IT architecture is good enough to implement this access network. And we certainly look forward for a high-speed network, which could be in a gigabit Ethernet or some kind of a fiber optics network. But sometimes we need a distinction to be made because, for example, these machines are located at different locations. So we need to identify this network also. So some kind of a technology which are either a virtual LAN or IP routing, because I need to identify the packets at the platform level from where they are coming in. Now, when we talk about the protocol or the middleware transport protocols, I just quickly touch upon because that's a more subject of the communication, but at least you should heard about these terminologies. So TCP/IP is the most widely understood protocol, and we all understand this is a very reliable protocol. But when you see that the reliability always come at the speed. So why this protocol is reliable? Because it's always detecting the packet loss. It's always keep on resending the packets again and again, and it will give you the acknowledgement that packet has been received. So I think with this kind of an understanding, you see that if you keep on increasing the overhead of finding out the lost packet, even reordering the packets and then sending the missing packets, it makes the technology inherently slow. And the kind of a time second, the delays, that latency I'm talking about, we need to find out on a better way to deal with this. So TCP/IP is certainly a reliable way to handle this, but this is an inherently slow because of its own nature. So modern communication requires a real-time transportation. That is what the need. And there's another protocol which is UDP. Normally people say it's an unreliable data protocol, but certainly this is unreliable. But the terminology is not unreliable. It's a user datagram protocol. But this is unreliable. But you have achieved a significant speed in communication with this UDP. So it's an unreliable, it's fine, but many cases it is acceptable also, because in a broadcast mode, you will be able to send the data much faster. You may not be worrying about whether the user has received the data or not. For example, if I just send the packet 10 times and make sure that some of the packets being received at the other end, I will be able to increase the speed. So it's not going to check everything. It's just sending the data in a broadcast mode. So non-critical data exchange can happen through this, because now I'm not ensuring the reliability of the data, but UDP is another protocol that can be used. The another protocol, which is COAP, which is being evolved, which is almost working on the TCP/IP with a limited functionality. So constrained, that's all the terminology, constrained application protocol is there. So this can be run on a small embedded devices also, because that's very important when you are trying to implement on the different device layer. You need to see whether it is capable of processing the TCP/IP or not. So for those cases, COAP has been developed, which is used in the web transfer in the constrained networks. It runs in the same way as the TCP/IP with a limited resources to run HTTP. Now we'll talk about the device level quickly. This is one example I would like to show you. I think let's see that you will be getting a right voice. Try to capture what is going on in this scene, and then I will come to this.
Are we there yet? No. Are we there yet?
Not yet.
Hey, are we there yet?
No.
Are we there yet?
No.
Are we there yet?
Yes.
Really? No! Are we there yet?
No.
Are we there yet?
No, we are not.
Are we there yet?
No.
So what you have seen in this short video clipping, which is from a movie that is Shrek, these donkeys keep on asking Shrek, are we there yet? So if you heard that term, that's only a voice in the video clipping. But from there, you see that how much annoying it is to respond every time back if someone keep on asking, are we there yet? Or whether the signal is true or false. So through this short clipping, I just want to give you an idea means how this will happen when we talk about the IIoT implementation. So in case of an IIoT, if you see that if there is a device in the field, and if I connected a sensor, and now I am running in a cloud services which want to know the status of this device, or the signal basically which is being captured from this sensor. So if I establish a communication mode in which I keep on asking, my application keep on asking, if I say, is it true? And every time the device respond no. So there's a one mode of communication which we call a polling. Means you need to keep on asking again, and your application keep on asking again with the devices. So if you have a limited number of devices, it's good actually. If you have 50, 100 or 200 numbers, it's fine. It's possible that your network can handle this kind of a communication again and again. but this is not a better way to communicate. Why I'm asking again and again. So once you reach the destination, I will tell you that's what the message that Shrek want to give. Donkey, just please sit on carefully and just watch the environment. I will let you know when you are there. So that's the philosophy over here. In the next, we want to have an event-driven messaging. We don't want then every time the application will be asking the sensor, is it true or not, or what's the value there. So I want to implement an event-driven messaging over here, and I think that's the way that this new protocols being evolved over here. So we would like to have a message bus which will be taken care of this kind of a communication, and the model that is being implemented is the publisher-subscriber model. So in that case, the devices is being publishing some information. The applications are basically listening to that data. And then based on that information, you can process that. So that is where the publisher subscriber model and the we call it a middleware software pattern is playing a bigger role over here. Now this pattern is very important to understand because your MQTT protocol is the one which is residing on that. So this protocol is the key to IIoT implementation, or I should say the IoT implementation, but this is not suitable for the time critical scenarios. But most of the applications are not time critical, and we will be able to easily watch or implement most of the IIoT needs with this publisher subscriber pattern. So your different devices will be publishing some information, and different applications will be processing because they are subscribing to this information, and they can do that. So there are different protocols over here. MQTT is the most popular one, which is implementing this publisher and subscriber pattern, which is event-driven messaging actually. That is what can happen over here. And there are other protocols also being evolved. So I will not be taking you deep into these protocols because depending on your interest, you can understand that. But I just want to draw this graph to give you an idea about what is the difference between these protocols. So if you see that the type of communication that we have over here, some of the communications are taking microsecond to millisecond time. Some of the communications are taking millisecond to second time, and some of the communication is more than seconds. So in this case, if you see the real-time performance expectations, so if you have a device-to-device communication, that can be done in the 10 millisecond kind of a latency. If you have a device to server communication, that will happen in 10 millisecond to 1 second kind of a delay. And when you have server to server communication, this is coming out more than 1 second. So depending on your requirement, you have to choose which kind of communication is being implemented. And then the protocols are also different. Here we are talking about the data distribution services, that is DDS is the protocol that is being used. MQTT is something which is working in this range of 10 millisecond to 1 second, and we are having a communication between the devices to the server. And the another one is the AMQP, which is server to server. So I'm just skipping some of these slides, but explaining quickly on the MQTT part because of the time constraint over here. So MQTT is the way that you see that the publisher subscriber model, you need to have a broker in between. So this Mosquito is an open source MQTT broker. This is a software application that you can have. You can run this software application on any of the devices with you. And this will be then further communicating with these individual devices through the MQTT protocol, which is publishing and subscribing to some of the data. It can be directly with the sensors also, other than the machines. And then this broker is pushing the data to the cloud in an MQTT protocol. So that is how it can be done, and MQTT works over the TCP/IP only. So that's a most common protocol used in industrial IoT. This is XMPP. I'm just touching upon, not going into the detail. This is more developed for the messaging. So WhatsApp and other messaging that you see today are more done on this. So let's not go deep into this. Another one is the AQMP that is being developed for the financial applications, more reliable protocol over here. Again, it operates on TCP/IP. And it's server to server. The most efficient and the time sensitive is on DDS, that is data distribution services. So wherever we see there's a time critical applications, this is another protocol which is being implemented. So let's take a quick glimpse on the software design part. So this is what we are talking about, the taking the data to the platform, and post that you will be having applications. So in applications also, we will be using the API concept. So that is the application programming interface. This is again the functions that you will be writing, because on one side we have a data, that is the platform. Another side you would like to write in a business applications. These two are not to be done by the single set of people or maybe the same kind of a developer also, because most of the applications are developed by the IT team, most of the data being processed by your OT team. So in that case, the APIs are certainly like this. So your programmer send a request, this is a security guard which receive and validate the request. It will then further pass on this to the application. So then application will generate the relevant information from application side. It will give it to the person again. It acknowledges this and then give it back to the programmer. So that is the way of exchanging through APIs. I will be able to exchange, and most of the libraries we have today are implementing the softwares in this way. So what I will do, I will just want to skip some of the slides because we are already at 4:58. I would like to take some questions also towards the end. So what I just want to highlight, there is a need of understanding of this IIoT platform functionality, because I think this is what you see here. There's a device layer, then you set up an intelligent gateway, you identify the right kind of communication networks, you would like to process the data, and then finally you would like to build more business logic. So I think that's a quick building blocks for implementing high-level overview of the IIoT implementation. But when you come to this implementation, this cannot be done by one team of people, one group of people, and certainly you need to develop a lot of applications. So there is always a need felt for the IIoT platforms. That is what we call an IIoT middleware, because these are some of the key challenges. There's a different heterogeneity in the network. Scalability is an issue. There are thousands of AND nodes to be handled. You need to monitor these devices also, administer these devices also. And authentication of the data is also very important. It means that you need to write application for each of these functionalities, and that is very difficult to do at individual development level. So there's an IIoT platforms available which will be rendering all these functionalities. So I'm just touching upon these functionalities that are required from IIoT platform. Otherwise, you will end up in writing the application for each of these blocks on your own. So these are the, so comprehensively, if you see that all these functionalities are building the complete IIoT implementation, or that's a platform that you look forward. And we also want the security to be integrated at all layers. So starting from the basic connectivity, managing the nodes, processing the data, connecting the databases, visualization can be done, analytics can be done, then APIs based business logic can be implemented, and then your application can deliver that. So this is all that you are supposed to learn when we talk about implementing the IIoT. And there are options available. There are open source IIoT platforms available. So we are experimenting with some of these platforms in our foundation, and there are certain commercial IIoT platforms available. So one is with ThingWorks, which is from PTC. Another is MindSphere from Siemens. So in fact, in our lab, we have all these platforms available. Those who want to do experiments and identifying the suitability of these platforms, they comes with certain pros and cons. So that's very important before you decide a final platform for your implementation. You can do the same on AWS, that's a web services also, but then you need to connect many of the services together to build this. So I'm not going into the detail of that. This is one of the things about implementation we have on FSM IoT. So we will give you hands-on learning on this when you do detailed course on this. This is an interface with the ThingWorks, which is in a commercial IoT platform, where you are supposed to learn all these fundamentals and functionality that will be delivered as part of the hands-on learning. Now, the last question that I would like to discuss with you, we all understand the tangible benefits, because this is more relevant to the businesses, those who want to implement the IIoT. So always a question remains where to start and from where you will move from digital to IIoT. I think that's a very important question and put many people in dilemma. So if you are able to answer these three questions, and I think that could be a good starting point for you. First thing, what are the inefficiencies in your operations? You can do a quick exercise and identifying those inefficiencies in your operations. Later you can find out what kind of data would help in overcome these inefficiencies. And then you come to the communication process, need to place in order that data so that you can make a meaningful way out of it. If you are able to quickly address these three questions, I think you will be able to decide how to move on to this IIoT journey. And when it comes to the cost part, I think this power of 1% is very much realized by people. They said that if you are able to cut down your 1% of your operational cost and inefficiencies in your system, it will take care of all your ROI in this case. So your return on investment is well justified with if you are able to save 1% of your inefficiencies and the operation cost. I think that's a good example over here. That's all for the webinar today. I just want to give you a next step quickly in 1 or 2 minutes, what to do with after you get this overview part here. Next thing is that certainly we are going to have 2 courses coming up. One is on 3rd of October, which is too close now, but that will be on an implementation of industrial IoT. What we have discussed today is just on a building blocks and nice figures, but there are a lot of to be understood while you are dwelling deep into these technologies. So this is the one course, which is a little longer one, split into different sessions along with the hands-on sessions, follow up with some project ideas that can be done. And we are also planning to give a certificate in that course. So the another course, certainly it is coming out at certain cost only. So it's not a free course for the next one. So those who are interested, they can share or we will be sharing the information to all those who have registered today. So based on their interest, they can decide to go ahead. We have another overview course coming up, which is on machine learning on 14th of October, which is again an overview course. The way we have conducted today's session, we will take this session ahead. Yeah, Anupji, you are.
Dr. Jha, if you can clarify whether the course on 3rd October is specifically for industry people, or can students also attend that?
So it can be attended by the students also, because that's the starting point for learning the subject actually, and those who really want to experiment with. So it's equally valid for the students also. But take a word of caution from here. You need to have a basic understanding of the automation actually. Beyond that, otherwise it will be difficult for you to understand. So whatever I briefed you on the IIoT and with the basic understanding of the IOs and the PLCs and the programming, that is a prerequisite for that course.
Thank you.
And then we also have this developed this course, hands-on learning course, which is implementation of industrial automation and IoT on Codesys platform, which is a more openly available platform. So in fact, we have designed a complete course on this. So we will announce a suitable date for this course, but it is also now available on FSM skills to take up. So we will take up this course separately. And some of these glimpses we will try to bring out in the 3rd October course also. We already designed some of the hardware which is useful in learning the IIoT. So this is just a quick glimpse of those hardware. And some of the good reading references, those who are interested, they can take, because I have also taken some of the learning from these 2 good books over here. So I just want to acknowledge the content from these 2 books on Industry 4.0 and especially highlighting the industrial IoT part. Thank you. That's all from my side, Anupji. I think let's quickly have a glimpse on the questions posed over here. If I can respond to those questions correctly immediately. Yeah. Not many. I don't see many Q&A over here. So when we talk about IoT, the security of the data which is being transferred is the main concern. How could we improve the security of the transfer process? So I think that's a very, very important question. And that is why you see that when I have shown the different layers of implementation in the IIoT platform, I have put in a vertical bar of the security. So the protocols are certainly being designed to take care of the security part so that the data exchange cannot happen anonymously between the devices. So security is certainly coming out as a part of some of those industrial protocols as well. That's all. I think that's the only question. So at the end of the session, could we get a write-up on the subject? So certainly we will be putting the webinar video onto that course. As I mentioned that the way you can create your account, we will enroll you in this IIoT where we have more reference reading material and the content of the today's webinar, as well as so you can have a quick glimpse on what I have shown you today. I will quickly glimpse to the chat part if there is anything for me to address, otherwise it's fine. I think this is all. I think that's what some of the questions being answered directly, I think by our team also on the chat. I think that's all, Anupji, from my side. We have addressed most of the queries raised over here.
Thank you, Dr. Jha. I think it was really an outstanding session, and I'm glad that there are participants who have stayed on for the entire 2 hours. And we, as you said, we will be happy to serve them with more details. We will give them the information. And all of those who are keen to attend, please register yourself on the skills portal, browse through the other supporting material and stay in touch with us. For your friends who may have missed some of the earlier lectures, you can recommend the sessions on the basics of smart manufacturing. That really is a good starting point, and look forward to supporting you also in the fourth topic, which will come up later on machine learning.
So regarding 3rd October course, I just want to add that because there are some queries on the course fees and other things. We will certainly be sending you mail to all of you once we are finalizing the course content and the program details. Maybe in a day or two, you will be getting those details. So from there, you can make a decision.
Yes, the only point, Dr. Jha, I wanted to say is that there are many colleges representing, the IUC group. And for them, we have something dedicated which will come up later. So if there are students who have active projects, like I understand from Professor Balbir Singh, he has some students who have a knowledge of automation and some active projects. Such exceptions we will, of course, be making. So tell us your interest and we will certainly see if it is the right thing for you, and we will accommodate you if it serves your purpose as well. Thank you once again for all the audience to attend, and thank you, Professor Jha, for an outstanding program.
Thank you. Thank you.